You're watching Sleep Culture. Chapter 2. Fermi's Paradox. Picture yourself standing beneath a sky glittering with countless stars. The night stretches endlessly, each pinpoint of light representing a distant sun, many of which could harbor planets like our own. You take a deep breath, the vastness of the cosmos settling over you like a heavy cloak. In that moment, a question rises in your mind, one that has haunted thinkers, astronomers, and philosophers for decades. Where is everybody? With billions of galaxies, each containing billions of stars, it seems statistically impossible that Earth would be the only world with life. Surely by now, we should have seen evidence of intelligent civilizations beyond our own. Yet, silence. This contradiction is the heart of Fermi's paradox. Named after physicist Enrico Fermi, the paradox poses a simple but profound dilemma. If extraterrestrial civilizations are so likely to exist, why haven't we found them? Or worse, why haven't they found us? Enrico Fermi was one of the most influential physicists of the 20th century. Born in Italy in 1901, he displayed a genius for mathematics and science from an early age. He made groundbreaking contributions to quantum mechanics, nuclear physics, and statistical theory, fields that shaped much of modern science. Fermi immigrated to the United States, working at Los Alamos National Laboratory, a secretive research facility in New Mexico created during World War II as part of the Manhattan Project. Fermi's work on the development of the first nuclear reactor earned him the title Father of the Atomic Age. Los Alamos was a hub of scientific innovation, a place where some of the brightest minds of the era gathered to work on revolutionary technology. It's in this context, over a casual lunch in the Los Alamos cafeteria, that a conversation about the vastness of space and the possibility of extraterrestrial life took place. Fermi, known for his ability to reduce complex problems to their simplest elements, sat quietly as his colleagues joked about UFO sightings and space travel. Then, with a single question, he shattered the jovial mood. Where is everybody? The room fell silent. The simplicity of the question belied its profound implications. Fermi's colleagues, many of them seasoned scientists, pondered the unsettling paradox hidden within his words. Statistically, there should be thousands, perhaps millions, of advanced civilizations in our galaxy alone. Even if only a small percentage of stars have habitable planets, the odds of intelligent life evolving somewhere else should still be overwhelmingly high. And yet, we see no evidence of them. No interstellar probes, no alien broadcasts, no megastructures harnessing the energy of entire stars. It's as though the universe itself is devoid of intelligent life. Or perhaps something else is at play. The notion that we might be completely and utterly alone, that intelligent life might exist only here on Earth, is as terrifying as it is baffling. Modern astronomy provides us with some staggering data. There are an estimated 100 billion stars in our galaxy alone. Many of these stars have planets orbiting them, and a significant portion of those planets fall within the so-called habitable zone, where conditions could allow for liquid water and perhaps life. Beyond our Milky Way, there are over 2 trillion galaxies, each containing countless stars and planets. The numbers are overwhelming. The odds should be in favor of life being common, yet we have found nothing. Is it possible that life, especially intelligent life, is so exceedingly rare that it arises only once in a cosmic millennium? Are we the product of an almost impossible sequence of events, an anomaly in an otherwise lifeless universe? These questions push the limits of both science and philosophy. We must consider not just the statistical likelihood of life elsewhere, but the possibility that there are barriers, perhaps insurmountable ones, to the emergence or survival of intelligent civilizations. Some theorists point to the idea of the Great Filter. This hypothesis suggests that at some point in the development of life, there exists a nearly impossible hurdle to overcome. Maybe the filter lies in the origins of life itself, making the leap from simple molecules to self-replicating organisms exceptionally rare. Or perhaps the filter lies in the future, an existential catastrophe that most advanced civilizations fail to survive. If the Great Filter lies ahead of us, it implies that technological progress may bring risks beyond our control, risks that no other civilization has been able to navigate. The silence of the universe then becomes a chilling warning. Is it possible that countless civilizations have risen and fallen, leaving no trace behind? That we are hearing the echoes of a cosmos that has seen many come before us and fail? Or are we, in a vast and indifferent universe, truly alone? To consider this question a bit more deeply, let's explore this paradox through a story. Imagine you're an astronomer in the not-so-distant future. You're stationed at a state-of-the-art observatory on the moon's far side, shielded from the noise of Earth's technology. For years, your team has scanned the cosmos for signals, any trace of communication from another civilization, but the data feeds are always silent until one night. A faint repeating signal appears on your monitors. It's artificial, structured patterns that couldn't be the result of natural phenomena. Your heart races as you decode it. The signal seems to convey a warning, a message from deep in the void. Stay silent. They are listening. Your heart skips a beat. Who sent this message? And more importantly, who are they? You're suddenly overwhelmed by a terrifying thought. What if civilizations across the galaxy have learned the hard way that drawing attention to themselves is a fatal mistake? You find yourself unable to look away from the signal on your monitor. The pattern repeats with eerie precision, a whisper from across the stars. Questions flood your mind. Who sent this warning? What terrible fate did they fear? You initiate a series of checks to verify the signal's origin. It isn't static. It isn't interference from your equipment. It's real. The message's cryptic warning echoes in your thoughts. Stay silent. They are listening. You begin to imagine a vast hidden network of watchers, entities monitoring the galaxy for any sign of activity. Could it be that all advanced civilizations have learned to stay quiet, like prey evading predators in a dark forest? What would compel entire worlds to choose isolation over connection? You shudder, wondering if you're about to find out. Despite your fear, curiosity drives you forward. You attempt to trace the signal's point of origin, somewhere in a distant star system, light years away. But the data is incomplete. It's as if the message was sent long ago, a last desperate attempt to warn anyone who might hear. You record the signal, encrypt your findings, and prepare a report for your research team. But as you draft the report, doubt creeps in. What if sharing this information puts your own world at risk? What if the very act of acknowledging the signal is enough to draw attention? The monitor's glow feels harsher now, the laboratory colder. You're no longer just a scientist observing the universe. You're part of its unfolding story. You turn off the system, the silence around you suddenly deafening. As you leave the observatory, you glance up at the stars. The cosmos has never felt so vast or so empty. The story of that message stays with you, but it is only one of many theories that attempt to explain the paradox of silence. This brings us to the dark forest hypothesis, one of several explanations developed to address the unsettling question. Why haven't we found any evidence of extraterrestrial civilizations? The dark forest hypothesis is the idea that the universe is not empty, but rather full of intelligent life, all of it remaining silent out of fear. This hypothesis was popularized by Chinese science fiction author Liu Cixin in his three-body problem trilogy. In Liu's vision, the universe operates under a brutal, unforgiving logic. To broadcast your presence is to invite destruction from civilizations seeking to eliminate potential threats. The metaphor for this idea is chilling. Imagine a vast, shadowy forest filled with predators. Each hunter moves silently, careful not to reveal their presence. For in this forest, to be noticed is to invite annihilation. In this analogy, every advanced civilization in the cosmos behaves like a hunter, understanding that any signal sent into the void could be intercepted by something dangerous. This theory implies that civilizations capable of interstellar communication or travel might be actively hiding to ensure their survival. And perhaps, the few that didn't hide paid a terrible price. The fear here is not merely paranoia. It's a calculated response to the unknown. After all, we're dealing with a cosmos of incomprehensible scale. We have no way of knowing the intentions of other civilizations, especially those that might be far older and more technologically advanced than ourselves. But the dark forest hypothesis is just one of many proposed solutions to Fermi's paradox. Consider another possibility, the zoo hypothesis. This theory was first proposed by John A. Ball, an astronomer at the Massachusetts Institute of Technology, MIT. Ball speculated that advanced extraterrestrial civilizations might be aware of us, but have deliberately chosen not to make contact. According to this idea, they see Earth as a kind of cosmic nature preserve, observing us from a distance the way we observe animals in the wild. In this scenario, they may have placed a deliberate quarantine around our planet, choosing not to interfere with our development until we reach a certain level of technological or ethical maturity. To them, humanity could be in an early and dangerous phase of growth, unready for the responsibilities that come with galactic diplomacy. Perhaps they wait patiently, silently, for the right moment to reveal themselves, or perhaps they never will. Another explanation is known as the Great Silence. This theory takes a more sobering approach. It suggests that civilizations capable of interstellar communication may be rare, or even non-existent. One version of this idea is connected to the work of paleontologist Peter Ward and astronomer Donald Brownlee, who developed the rare Earth hypothesis in their book of the same name. They argued that the conditions necessary for complex life might be far more stringent than previously assumed. Perhaps planets capable of supporting advanced civilizations are exceptionally rare, or perhaps the emergence of intelligent life is a fluke of evolutionary history. Alternatively, Charles Lineweaver, an astrobiologist, proposed that most civilizations might self-destruct soon after achieving technological maturity. This concept overlaps with the idea of the Great Filter, an existential barrier that prevents most intelligent societies from surviving long enough to communicate across the stars. If this is true, then the universe may be a graveyard of civilizations that reached a certain threshold of advancement, only to perish before they could explore the stars. And we, standing at the edge of that threshold, might be walking a precarious path ourselves. Of course, there's also the possibility that we are simply too early in the cosmic timeline. The universe is roughly 13.8 billion years old, but intelligent life on Earth is an incredibly recent phenomenon in that timescale. Perhaps the majority of intelligent life has yet to emerge. We might be among the first civilizations, pioneers in a vast and uncharted frontier. This idea aligns with what some scientists call the firstborn hypothesis. While no single individual is credited with originating this hypothesis, its implications have been discussed extensively in astrobiology and cosmic evolution studies. If true, it would mean that the responsibility of shaping the galactic future might fall to us. Then there are those who propose that we have already been contacted, but we failed to recognize it. This concept was famously explored by Arthur C. Clarke, who once remarked, "Any sufficiently advanced technology is indistinguishable from magic." Alien communication might not come in the form of radio signals or visible spacecraft. Their methods of contact could be so far beyond our current understanding that we simply can't perceive them. Imagine an ant colony at the base of a supercomputer. The ants, incapable of comprehending the device's purpose, go about their lives unaware of the complex intelligence towering above them. Could we be the ants in this scenario, blind to a reality operating on a vastly different level? Ultimately, each hypothesis reflects our deepest fears and hopes about the unknown. The dark forest hypothesis paints a picture of a universe where fear governs all. The zoo hypothesis offers a vision of cosmic guardians watching over us in secrecy. The great silence reminds us of the fragility of life and the possibility of our own extinction. But as with all paradoxes, there is no definitive answer yet. We are left to search the stars, pondering our place in a cosmos that continues to withhold its secrets. Each new discovery, each new Earth-like planet or unexplained signal brings us closer to understanding. The question persists: are we alone, or are we simply too far away, too early or too small to hear the chorus of voices hidden among the stars? And if the silence ever breaks, will we be ready for what we find? The responsibility of shaping the galactic future might fall to us.